break down that 100 in this vector tree, okay? And then we're going to circle our pairs. We said we had a pair of 2 and a pair of 5. So we circle the 2, the 5, and we cross one out. Now, out of x to the third power, we had 1x pair, 1 leftover x. Out of y to the 6th, we had 3y pairs. 2 times 5 multiplies to 10. Pair of x, y to the 3 goes out. And the only leftover on the inside was x. Now, we're over here. 91. We said 7 times 13. Is everyone with me? Write this stuff down. So, 91 is 7 times 13. And there are no pairs with 7 and 13. 2 prime factors. Let me talk to the firm. Okay, so 91 is going to stay inside. We have 1x. That's not a pair. Leave it there. Y to the 8 actually does have 4 pairs, so y to the 4. Circle that. Now, z to the 13. What you do is you prove it. So, 13, take away 1, 12. How many pairs are in 12? 6. So z to the 6, but remember, there's that 1 leftover z loner. Does that make sense? 6 plus 6 is 12, plus that extra 1 is 13, right? Now, what's going out? Circled stuff. So, y4, z6 is going to go out. Square root. Now, what's left over is these 7 times 13, which is, of course, 1. So 91 staying inside, doesn't break down. And don't forget the x. The x was a loner by itself, and z had an extra loner, 91xz. Cool. Now, the last 2 days we've been doing square root, which is couples. Today we're going to be doing cube root, which is triples. Okay, so let me pass this out.
Check.
Perfect cube. Y'all ready? We talked about square numbers, which is a number times a number, right? Now we're talking about cube numbers, which are number times the number times the number, right? What about the other one? So, this one does have a story. Actually, no, the story ends because we're not going to talk about triples. That's weird. So, but 8 is what times what times what? No. No. 2. 2 times 2 is 4. 4 times 2. I see it. I can see it. 2 cubed. All right? So, now 27. Take a wild guess. What do you think that was going to be? 3 times 3 times 3. 3 cubed, right? Let's fill these all in. remember what I. All right. So 7 cubed, 8 cubed, 9 cubed, all the way down. Now, do I want you to memorize these? No. You don't have to know cubes as much as often, okay? But those are your cubes up through 11. Now, on the other side, if you take a cube root, y'all know what that is? Little 3 on the square root side. Cube root a cube number gives you a whole number. So the cube root of 8, what times what times what is 8? 2. Okay? Who answered over here? All right, and then cube root of 27 is 3, right? 3 times 3 times 3 is 27, and so forth, right? All right, right. Oh, what? You did. You wrote that down. You didn't write that down? Oh, okay. Well, then I guess I was right, after all. True, just like I'm going to be right about this. Who's going to win tonight, right? That's fun. All right. So, oh my gosh. Don't worry about it. So, number one. Number one. All right. So, we're going to do, how do you say this? Cube root of 24. Now, y'all know square root was pairs. Now, cube root's going to be, you can call it triples or triads, however you want to say it, okay? So, is everyone with me? Okay. So, let's break it down. 24 is 2 times what? Thank you. 2 times 12. And then 12 is 2 times what? 2 times 6. Very good. And then 6 is what? 2 times 3. Now 3 is prime. So we're done doing the factor tree. Now here's the big difference. Cube root, I need 3 of a lot of a 3 of a kind. Triples, triads, however you want to say it. Okay? So 3 twos. So let's circle all 3 of them. Now, this time there's 2. What are we talking about? Bear traps or line mines? Whatever it is. They're gone. They're set. Okay? So anytime there's a circled anything, it's just think of it as one number. So it's just because I just want you to not get confused and think you're not gonna re-multiply them. It's just 1, 2 is gonna go out. Okay? So here's the deal. What I circle always goes out to the left, right? So let's write 2 out to the left without phones in our hands. Our headphones in our ears, please. Please. Thanks so much. The other ear too. I know it's in there. So 2 square root, and what's left over? What's my loner? 3. That's it. But actually, no, that's not it. That little 3, if I don't write that little 3, that's wrong. Okay? It's got to be a cube root. Put that little 3 right there. If you don't write a cube root, then I'm going to think it's a square root, and the square root ain't right, right? All right. That's why it's simplifying. You're simplifying it. You're making it more simple. Yes. Now, example 2. Break down 120. See if you can break it down. 2 times. 2 times what? 2 times 60. Now, 60 is 2 times what? 30. 30 is 2 times what? 15 is 2 times. It's not 2. It's what? 3 times what? 3 times 5. Now, these are all gone. Right? Do I have any? Do I have any triples? Any triads? 2, 2, 2. Boom. Boom, boom. All right. No, no, no. They're just peacefully in their old age gone. Now, we got a triple 2. That's going to go which way? Out to the left. Okay. Now, if I have 2 loners, just like before, they're going to multiply. 3 times 5, 15. One last little thing. What kind of root is this? Cube root. So put a little 3 there. So again, when you see the little cube in the root, you're going to circle 3 of them. True. Now let's do example 3, 1080. That's a big number. So 2 times 540. Okay, 540 is even. 2 times what? 270. Okay, 270 is even. So 2 times 135. Does 2 go into that? Nah. So let's try 3. 3 times what? 135. 3 times 45. True. Okay, 45 is 3 times 15. And then 15. 3 times 5. You got to be able to do the factor tree first correctly. And remember, when you break them down, these are gone. I don't need these anymore. Now, do I have any triples? Well, before the 3s. Oh, there's only 2 2s, right? That's it. Wait, that's a 2. All right. So you're right. Those are 3 2s. That's supposed to be a 2. The ugliest 2 I ever seen. So, all right. And then, hey, I got 3 3s. Wow. All right. So, tragedy, 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 tragedy. Now, triple 2, triple 3. 2 and 3 gonna multiply. Okay. So 6, square root, not square root, but cube root. And then what's my loner that's left over down here? Got that 5. All right, on the back. You can wait. We got 4 more. We'll knock these out. We'll do this one a little bit faster. 2160. Woo! 2 times 1080. All right. Now, this is the exact number we just did, so break it down the same way. 2 times 540. 2 times 270. 2 times 135. 3 times 45. 3 times 60. 3 times 55. All right, that was a long tree. How many pairs do I got? Pair 2? Stop saying pair. Triple or triad. A triple 3 and a triple 2, right? True, there are 4, but we're only going to group 3. 3 2s, 3 3s, and remember, now sometimes we forget things because I can tell because we forget. There you go. So, remember to cross those out. Now, the triple 2 and the triple 3 go out and they multiply and make 6. And then we put the cube root, and my loners are 2 times 5, which is, all right, now, example 5. How's this different? What do you see out front? You can't see it if you're looking at your phone. So what's out front here? What's the word for it? Coefficient 5. So I circle it because I think of it as like it's already a pair outside. 5 is already outside. Now let's break down 40. 2 times 20. 2 times 10. And we say now, thank you very much. 2 times what? 5. And then 5 is prime. Do I have any triples? 3 2s. So, here's the deal. Circle your triple. Cost you out. Sorry. Anyway. So, circled 3 2s. That 2 is going to go out. What's already out here? So the 2 and the 5 have to multiply. That's going to go out. Multiply with that. So we get 10 on the outside. Cube root. Now what's my one loner that I didn't circle? 5. 5 stays inside. Okay. Now, let's amp it up a little bit. What if there's variables? So instead, y'all remember last couple days if we, hold on. So when you have variables, which is like x and y, and you look at the powers, remember we were kind of dividing it by 2? Well, now we're going to be looking for pairs of 3. We're doing cube root, right? Let me show you what I mean. Example 6. First break down 48. 48 is 2 times what? 2 times 24, right? Is everyone with me? Looking up here? And 24 is 2 times 12. And then 12 is 2 times 6. And then 6 is 2 times 3. Okay? Do I have a triple? Triple 3, right? Sorry, triple 2. You're right. Circle those 3 2s. Cross 2 out. Now, before I go any further, does everyone see I have x to the 8th power? Okay? You have x. So x to the 8th power. So, hold on. Follow me here. Follow me. There's 8 x's. Now, if you drew them all out, I don't want you to circle 2. We're doing cube root. I want you to circle 3, right? Pair of 3. No. Follow me. Okay. I was talking about this x. See how it says x to the 8? So that's why I drew 8 x's. Now I'm going to circle 3 of them, 3 at a time. So here's a triple, here's a triple, and then 2 left over. So I got 2x loners, loner x, and then I got x, 2 triples. So that means x to the what power? 2, okay? Now, I have a pair of 2 and x. So what's going to go outside? What number? 2, and then we said x and x makes x squared. So 2x squared, check it out. Square root, what are my loners? Loner 2, loner 3, loner x, loner x. Right, weren't there 2 leftover x's over here? Okay, so 2 times 3 is 6. X times x is x squared. Okay, so it's kind of weird. And, you're very right, it's supposed to be cube, right? Cube root, that is. Not little 3 there. Put a little 3 there. Cube root, not square root. Cube root. Okay, last one. Make it just as hard as possible. So, does everyone see the coefficient 2x? All right. Break down 54. 54 is 2 times 27. 27 is 3 times 3 times 9. 9 is 3 times 3. Those are prime. So check it out. Boom, boom, boom. Do I have any pairs? Sorry. Ooh, triads, triples, whatever. Do I have any threes? Groups of 3. Do I? Why'd you say no? What I do? Because I do, actually. So 333 is a triple. Now, that means I have a 3 going out. What's already out? 2. Okay? Now, what about x to the 4th? X. How many triples, how many groups of 3 do you see? 1 pair of 3 and 1 loner, right? Okay, so what's going out? It's the 3 and the x, and already outside is 2 and an x. So 2 times 3, 6, and then x times x squared, right? X squared. And then what are my loners? 2x. Okay, and it's got to be a cube root, a little 3 there. All right, now, of course, I showed you the easier ones all the way up to the silly hard ones. You have the whole breadth of it. That's called cube rooting. The big takeaway is you're doing 3's instead of 2's now, right? And how do you know? You look for the little cube root sign. So, if you're still working on square roots, okay, if you've done at least the front side, turn it in. That's fine, okay? But I'm going to pass out the cube root assignment now, and we're going to do that, okay?